In Demo 3, we'll run the trains and try to identify the commands used as the trains are running. We'll review the hardware in more detail. In Demo 4, we'll demonstrate testing the Z-Stuff detector, and we'll discuss the labels on the Atlas control switches. Now what we'll do is run these trains again, and this time we'll try to call out the commands that are actually causing these locos to stop and start. In DCC, the command to address a certain loco is a select command. In other words, that red loco back in the rear, the F3, that's number 24. So if we say select loco 24, that selects that loco. And then we can send a speed forward 8 command to start it up. Likewise, the green diesel over here, that's number 779. So we'd say select loco 779 and then speed forward 8 to start that one up. And the steam engine back there, that's number 3444. So we'd say select loco 3444, speed forward 4 to start that moving up in the yard. All right, we'll push our start button, and we did a select loco 24 and a speed forward 8. Now the next thing that will happen is when that crosses in front of the detector, we'll send a speed forward 3 command to slow it down. It's already selected, so right about now when that goes to red, we say speed forward 3, then we select the green one, 779, we say speed forward 8 to put it out on the main line. The steam engine, we say select speed loco 3444, speed forward 4, and then when the time delay ended, we said speed forward 0, and that stopped it. Then we selected the F3 and said speed forward 0 to stop that one. So those 2 locos are stopped. Now the one running on the main line is coming in. I'm going to open the repeat switch. Now that loco's already selected, so when that crosses the detector, the controller will send a speed forward 3 command to slow that down. Select 3444, the steam loco, speed forward 8, select loco 24, the F3, speed forward 4. Now we're running a 14-second time delay, and when that ends, we'll send speed forward 0 commands to both of those locos. We'll actually say select loco 24, speed forward 0, select loco 779, speed forward 0. That gets those 2 locos stopped in the yard. Now the steam engine is already selected, so when that crosses in front of the detector, or actually when the first car activates the detector, we say speed forward 3. We say select loco 24, speed forward 8, select loco 779, speed forward 4. Now we're executing a 14-second time delay. Now the repeat switch was open, so it got to the bottom of the program and it stopped everything. We basically said select 779, speed forward 0, select 3444, speed forward 0, and select number 24, speed forward 0. So those are basically the commands we send to have this system operating like it does. Let's take a quick look at our components here. This is our push button for the public we talked about before. This is our control board, and that's the programmable train controller, the NCE Mini-Panel. That's basically, I tell people, it's the equivalent of a cab, but having a robot controlling the cab. It does the same thing as sends commands out. These are Atlas number 205 slide switches, and when they're away from us, they're off, and if we push them in, like that, they're on. They make a constant connection, and all we're doing is grounding inputs. There's 9 of them, so we can ground 9 different inputs. And when this thing goes down through its programming, you can have it check inputs, and if the input is grounded, you can have it do one thing. If the input's not grounded, have it do something else. And here's our connections, just 2 of them. This is the terminal 1 where the push buttons are connected to start things, and this is terminal 6, I think it is, where the detector is connected. Then this is an Atlas number 56 momentary switch, and we use the 1 position to start things. This button does the same thing as this button over here. You push it down brief momentarily, and it grounds input 1, which starts things up. And then if we push it over here and push it down, it connects to the reset terminal. It resets the mini panel. That's like a hard stop if you need to do that. And this is a standard NCE Pro cab, and then going over here is the command station. This is essentially equivalent to what MTH calls a TIU. And we have power coming out here to this terminal block, 2 wires going over to our track, and then 2 wires going out on this 4-wire cable, which go down to power the detector. Then the other 2 wires from the detector come into the inputs. And here's the power unit for the command station. And then down there, as we mentioned before, is the Z-Stuff detector. And as mentioned, this is just a continuous loop of track. There's no blocks in it or anything. We've got 1 power input here, and we've got about 5 other power connections, but you can see there's no wires going to them. We can just use the lights. If the lights are on, that tells us the track is getting power there. Most people I've listened to that use the MTH real tracks, which is what this is, they sometimes have trouble losing their power. And so if I see if one of those lights down there on the layout went out, that means I lost a connection somewhere in one of my pieces of track, and I got to go troubleshoot. I picked up this detector and moved it over here next to the control panel. One thing that seems nice about these infrared detectors is you don't have to connect anything to the track. It just sits alongside the track, so there's no blocks to cut in the track and wires to hook up and stuff that ties it down. You just pick it up and move it if you need to. But the mini panel is set up such that if there's no engines running, I've actually pushed all 3 of these switches corresponding to the 3 engines over to the off position, so the program will execute from input 1 down to input 30, but it'll just keep looping because there's no engines to run. And let's start it up, and you can see hopefully over here where I'm pointing there's a red LED blinking, and what happens is when this thing sends a command, that LED blinks, and it's sending a command to throw a turnout that doesn't exist, a dummy command, you could say. It'll send commands happily to things that aren't on the system. It doesn't know, so we send a dummy turnout command to a non-existent turnout, and we can make that thing blink, and we put a delay statement in there. I think it's a quarter or a half second, because it can't blink at an infinite speed. It'll quit. But we have it set up so that now that's green. If the detector relay closes, we have our program set up so it'll sense that. You see how that went to red, which closed the relay, and this thing detects that, and it adds an extra delay. You can see it's still blinking, but it's slowed down quite a bit. And that basically tells us that this detector is communicating with our programmable train controller, the mini panel. If we move that car away such that it goes green again, you can see it goes back to its regular speed. And we got to have the repeat switch closed to do this, because it's repeating the program about twice per second. And if we open the repeat switch, it quits and stops. If we close the repeat switch and start it up again, it'll start blinking again. But using this, we can test the detector again. If that detector goes to red, it closes the relay, which is back here, which adds an extra delay to that blinking and slows it down. I should probably go over these labels on the control panel a bit better. These three here are for the three engines, and to run all three engines we need to have all three of those on. The off is this way and on is this way with these Atlas switches. So these three control which engines we're going to run, and we can use these switches to run all three or any two. And then over here, this is our repeat switch. This controls whether it makes one cycle or it runs continuously. This label says more yard delay. That makes the trains pull up further in the yard. The way it's programmed now, it changes the delay from 14 seconds to 19 seconds. It adds 5 seconds when we close this switch. But of course, you can program anything you want. This switch says front train keep moving. That just when we close that switch, the controller here checks if that switch is closed, and if so, it doesn't send a stop command to the front train. It just lets it keep going. So we go. Here's our three engines. Here's this switch adds some mainline delay, and we use that mainly with the horn. If we put this switch on, that means it'll blow the horn someplace down on the main line partway around the loop. And how far around the loop we want it to go before we control the horn, before we blow the horn, is controlled by this main line delay. Say if we add 15 seconds of main line delay by closing this switch, it'll make it go 15 seconds further down the around the layout before it blows a horn. We just have to make sure this isn't too long, that this stuff isn't done before the train gets to the detector, because the mini panel, the controller, can't be executing a delay statement when the train crosses a detector, or that'll be missed. And then this is a station stop. This label says station stop. So if we put that on, it checks that input, which happens to be 24, and it'll make the train do a brief station stop. And if you ever do something like this yourself, you don't have to do it the way I did it. You might find a way you like better. You can experiment with it. That's the fun of it. Now I'm probably deluding myself, thinking I'm going to talk, 70-year-old three-rail O-Gaugers into doing this programming, but maybe their grandkids is a good place to start. After all, what could be more interesting to learn programming than programming a model train?